Constraints are really important, and they're a consistent topic not just amongst SQL Server, but amongst all flavors of SQL, whether that be MySQL, Oracle, Postgres, IBM, Azure SQL. It's always there because they are the gold standard way to enforce data integrity. And like we said here, they're predefined rules and restrictions that we implement when we're creating a table structure. So when we do our usual create tables statement, we would then have to assign potentially primary keys. And at that point, when you assign the column name, the data type, the key potentially, and at that point you would also assign any constraints. And constraints are really important because a lot of the time you see in business scenarios with large organizations to small organizations, the data will usually originate, if there's a mature data system, in a proprietary source app, usually, or a website, or a web app, or a portal. And from there, data will be being inputted by users, being collected in forms, and so on. And the issue there is you often find that software developers obviously don't have a data background, so they aren't so concerned about ensuring that clean data comes through. So usually what happens is within SQL, at least initially, you will get a dump of dirty data. And this is where we need to fix it. You could think of this as a staging area. So how do we do that? Well, we do that by implementing constraints, potentially after we've imported data into SQL, maybe pipelined it in. When we're creating our tables, we need to really have rock solid constraints. So here's an overview as to the constraints and what they actually mean, and some real world examples as well. So not null. Now this restricts null values from being inserted into a column, with the default behavior being that nulls could be inserted in on the flip side of this. Now this is really important because quite often null values are a huge question mark when working with data. We don't know if they're allowed to be there. We don't know if they pass through unknowingly. And then when we actually get to collecting insights, if we haven't defined what those null values are, we don't know if those removing nulls or including them, either way, will skew the data. And then it's an extra piece of work to go away and have to find out whether that nulls will impact our insight. And even then, when you approach a stakeholder, there's a chance that they won't actually know either. So it's better just to eradicate this at the start with blue sky thinking this would actually be sorted at source. But if not, when it comes into SQL, we would implement the not null constraint wherever we can. So things like mandatory fields, first name, last name, sales value, all these things shouldn't be null. And any sort of contact details as well while we're on that topic, such as email, because that would in other systems comprise master data, a customer's master data. So that'd be really important to have that there. Now the next constraint's quite interesting. It's check. And what check does is it verifies that any value being imported into our table or inserted into our table satisfies a condition. So what's some examples of these? Well, maybe we have some sort of portal and the user has to be at least 18 years of age. So we would say if the age is greater than or equal to 18, then the data can pass in. Or we could say, if it's within a certain region, the data can pass in. Or if it's within a certain year, the data can pass in. So we can actually evaluate conditions. And I just think that's a really cool function, to be quite honest, functionality to have there. Because it makes everything really specific. And if there's one thing we want to be, or two things actually, as data professionals, it would be specific and rigid, especially at this stage where we're sort of inputting data into tables. Default value, simple enough, automatically assigns a default value if no value has been specified for the field. That's clear. We don't need to go into that too much. Some classic default values you might see are something like NA, or maybe the default value for a certain product if no other product's been specified in inventory, maybe. That could be an idea. Unique, if there aren't unique values, being inserted in. So duplicated values, such as an ID of 1 appears twice. Uh, that wouldn't be allowed if we'd specified the unique constraint. So on the second ID column, where the value is duplicated, let's say the second instance of 1, the import of the data into the table would fail. So we get the first lot, but not the second. So it's really important if we do go ahead and use unique, we've got to keep on track of the potential for things to fail and be mindful of that as to how we sort of strategize importing data, because we don't want to be at a stage where everything's sort of siloed off. Primary key, hugely important, uniquely identifies each record in a table. Typically, your primary key is used as well to connect tables together. So we would want this to avoid data redundancy. So quite often, let's say we have a customer table, the primary key would be the customer ID. And in a sales table, we would just have the customer ID represented because it takes up much less data than, again, importing the customer name, the customer location, the customer headquarters, the customer email. We just have the ID and we connect things that way. And that's where the foreign key comes in. Really, you can think of a foreign key as a primary key table. A primary key from one table is now within another table, and that becomes a foreign key. And that's how we could link things together. So, in summary, constraints are one of the most important aspects of SQL. I think they aren't covered as much as they should be because a lot of people get to querying and they're satisfied, or they're in roles where querying really is all that matters. But when you come to the stage, and you inevitably will at some point, when you have to build tables or schemas, even you may have to build schemas if you're working in something like Data Factory, pipelining data to SQL, you will need a working knowledge of constraints. And it's never a bad thing, because these principles as well cross-pollinate whatever application you're using with regard to data integrity. So that could be SAP, that could be Power BI and Power Query, that could be Tableau, that could be even Excel, that could be Python. Data integrity is essential. And a lot of these constraint fundamentals should be applied in a lot of other areas of life to keep things rigid, specific, reliable, and accurate. We previously looked at constraints and how fundamental these are for ensuring data integrity. Now, the purpose of this course is not to get you uh, towards building databases like a database administrator would. We want to sort of align this to the relevant skill set and beyond of a data professional, an analyst, potentially a data engineer, and so on. So there's all these different avenues to go down and a really good foundation of knowledge. However, that being said, constraints is something that is just extremely valuable because it essentially governs the whole data integrity of your SQL environment, which is most likely your data warehouse. So that will sort of act in the middle as a staging area, and it will retrieve information in an ideal world, live information from an app or refreshed a few times a day. And then it would take it to a business intelligence tool, maybe a few other places along the way for enrichment, potentially. Sometimes you have, instead of a source app, a lot of CSV exports or Excel files, which are a lot harder to govern, which means it's even more important in SQL to have our constraints set up properly. So we went over an overview, and I went over the core concepts. Now I want to show you how these practically work when creating tables in SQL Server Management Studio. So we'll get right into it. I'm going to sit within the test database here, and I'm going to create a new table, and I will call this suppliers. Open my parenthesis, and we're ready to start specifying our columns. Now, when we specify our columns, it's good practice. Well, we have to specify the column name and the data type. But then it's best practice to have some sort of constraints there. So I'm going to go over a lot of the fundamental constraints that we looked at previously. So primary key, not null, default, check. Check constraint's a really interesting one. And we'll look at how these can be used to enforce data quality, data integrity, data accuracy, and whatever else you can think of that's a positive feature for maintaining your data. So the first column, we'll only have about 4 columns here, just as an example. The first column will be ID, and of course, we want that to be an integer field, so a whole number. And then that we give that a constraint of primary key. Now, primary key is interesting because it has two huge purposes. Number one is to connect tables together when we join them. After all, the whole purpose of a relational database is to segment the data and then join it together at a later date for performance. However, another huge element of the primary key is that automatically assigns an index. And indexing is probably beyond where we're going to go with this, but indexing essentially just helps um, guide SQL, the engine, as it's making queries and calculations to get to the correct spot. So think of it as indexing a book. You have an index or a bookmark, or a list of important pages in your index. And that's essentially what we're doing with a primary key. We're indexing or giving a value to each row so that when we actually go in and use things like we're joining, we're using where conditions, having filters, it's a lot quicker for the SQL engine to actually know where to go. And it means that it doesn't have to flip through a whole metaphorical book. It can pinpoint where it needs to go very rapidly. So that's the idea. So primary keys, incredibly, probably one of the most fundamental constraints that there is, if not the most fundamental constraint. And then what I'm actually going to do is give this the identity property. Now we could just have an integer ID and we could manually populate this. So every time we inserted values, it could be 1, 2, 3, 4, sequential like that. But of course, we want to automate as much of the process as possible. For starters, less human error, because if we were populating figures, we might not have solid constraints. We could forget to put in an ID, and then suddenly we notice that, and the whole process is in question. The accuracy is in jeopardy. So identity will actually just we don't even need to specify anything when we're inputting values into our other columns. We can leave the ID blank and it will sequentially add that every time we add a value. It will add an additional integer value from 1 into the rows. So that's really helpful. So for that initial column, we're pretty much set for the constraints. So I can add a comma here and go into the next area. So the next column that I'm going to have is going to be supplier name. And I'm going to specify this as varchar 100. So we've given it a name and we've given the supplier name a data type. So essentially we're going to expect a string. So we've got varchar just to accept characters, and 100 within the data type essentially means that we're going to take up to 100 characters. If it was over that, we would reject it. Usually this is done as a storage consideration and a performance consideration. Naturally, on layman's terms, if you have a lot of data sitting across a lot of wide tables and a lot of columns, it's going to get problematic. So we want to limit things. And if you limit at every individual transaction level like this, then it's helpful. If you save up, if you make little changes, it eventually makes a colossal improvement. So that's what we're aiming for. And then after we've supplied the data type, what we're going to do here is give the not null constraint. So what's happening here is there would never really be a condition where we wouldn't input a supplier name, or from a data perspective, we would always want to have a supplier name there. However, someone importing the data might not have that same concern as us if they just want to get on with their job. So we add not null, and it means that the import of the values will fail if someone tries to insert values. Maybe this process is through a form into a proprietary application through to SQL. It would just fail because we can't have null values. That's why we have the constraint. Then we could go back, query it, and fix it at source. So I think the only constraint we really want in supplier name is not null. We will look at default, but we wouldn't really want a default supplier name because we would assume in the grand scheme, we could have tens of thousands if we're a large company. So the next one here is city. This is my next column I'm creating. And again, I'm going to give it varchar 100. That should be fine as a data type. Now I'm actually going to give this one a default value because the city isn't as important for our day-to-day duties and how we manage the data. So let's say in this case, we've got a lot of trading around London, not much anywhere else. It would be a pretty safe bet that if no one wants to input a value, we could have a default of London. In a really ideal world, you wouldn't do this, but it's good to demonstrate how the technology works. So I'll say default, and then within my single quotation marks, put London. So that's going to default to London if no other value is entered, instead of having blank or null values. And then lastly, we've got a supplier score. This is where we're going to use the check constraint. So that's interesting. So we've got default value London, and then we've got a supplier score. So that's an integer value. That's just sort of scored from, in this case, from 15 to 100, or 15 upwards, we'll say. And it's an integer data type. And now we introduce the check constraint. And it's pretty much what it says in the tin. It checks. So it checks for a condition. It checks that evaluates to a Boolean true or false. And then it will allow the data to pass into our table, or it won't. So it's sort of the gatekeeper here. So within parenthesis, we'll just say, and like I said, there's business logic here we've got. We're replicating a scenario where anyone who's a supplier always has a minimum supplier score of 15. So we need to check that the supplier score is greater than or equal to 15, because if it wasn't, that clearly denotes an error, and we don't want inaccuracies or errors to actually creep their way into our table. So this is pretty good. We've got a good amount of constraints for such a small table, and that's what we'd be aiming to do. The sort of, when you're in software development and things, the priority is quite often, fast movement, get things done, um, get the product out there for people to use. But from a data perspective, we kind of sit on the other side of the fence. We want things to be nice and rigid and controlled, because that's our best way of ensuring that we don't have a whole host of dirty data. Most companies do, and that's why data professionals are hired, one of the core reasons. But yeah, we want to try and limit that as much as possible. So we have our table here, and what we can do is just execute. And it says that the commands have completed successfully, so that's a good sign. If we refresh your tables within our test database, or wherever you were building this, if you were building it and following along, we now have the suppliers table. So there's nothing in here. If we were to select all, we would just get the column names. So select all from suppliers, and what we get here, we execute, simply the column names, which means we need to input some values. And we're going to do a few values the wrong way to show you how this sort of works when we're trying to input data that directly conflicts with our constraints. So we can say insert into suppliers, and then we need to say values. There are other ways to input data into tables. You will have seen or will see in this course. There's a way to use select and union all, which is interesting. We can select into if we have another base table we're interested in, but this is sort of the standard way of importing data into tables, obviously, unless it comes through a sort of live pipeline or system. But if we were just doing it here within SQL, this would be how you traditionally add values. So There's no need for us to put in a value for ID, like, for example, 1, or for example, in the next row, 2, because it's going to do it for us with the identity property. So we'll see how that works. Now, supplier name can't be null, so we'll just say something like fast chip. And the city, we'll do it properly in the first instance. We'll say Manchester. So we don't get the default value. And the supplier score needs to be greater than or equal to 15 and an integer. So I'll just say 58. Now let's see what happens when we input this into our table. We get one row effective, which is good. That means it's passed. We don't get any of that nasty red error message there. So we'll Control and R, and we can now query our table. Select all from suppliers. Help if I got the casing right there. There we are. And you'll see, like I said, the ID is automatically populated. The supplier name's taken what we've provided, the city that we've provided, and the supplier score. So let's do this in a little bit of a varied way now, and let's see what happens. So what we'll say is we'll just take it from here. Supplier name, we'll give a supplier name in this instance. We'll just say action servers. And this time, we're actually not going to specify a city. So what we could do is we could actually explicitly state the columns that we're actually we won't. We'll do it this way. We'll do action servers, and then in the city we won't type anything, and we'll go for supplier score int check, and I will try and input a score of 5. And we'll insert these values and see what happens. So column name or number of supplied values does not match table definition. Now that's because we didn't actually input anything in where we should have had default. So that's the first issue. And then we also will have an issue here with our supplier score. So we'll need to watch out for that as well and modify that. So let's go ahead and actually fix some of this and look to action it properly, and we'll go about doing things the right way. So first of all, when we're importing in just a couple of column values, we'll map out what we're actually doing. So we'll say supplier name, and we will say supplier score. There we are. And we've got action servers, and we've got 5. So let's see what the error message reads as now. So we've started to map out if we're inputting in less than the sort of 3 values, because we would never put anything in identity. And it's now saying the insert statement conflicted with the check constraint here. Now that's because our supplier score is less than 15. So let's correct that. Make it 60. And now execute. And we get one row affected. So let's see what happens here. So if we select all from suppliers again and click execute, you see now we get fast chip, Manchester, supplier score 58. However, what's interesting is that we need to be careful because we had an error, and therefore sequentially the identity has bypassed where it should be. So it should be on row number 2. There are ways to manually override that. It's out of the scope of what we're discussing right now, but we need to be careful with identity. But what is helpful to note here is that we have our action servers and we specified our supplier score. We didn't input a city, but it was still accepted because we have a default value of London. So now if we were to do everything the right way, let's give that a bash and we'll say values. We will add in a new supplier name. We'll just call it computer repairs, and we will specify a city. We will say Edinburgh and a supplier score of 33. And we'll just map that out if we want to be explicit here, but we're actually hitting all of the columns, so we don't need to actually map that. We can just input it as it is. So we've got computer repairs, which satisfies the not null constraint because it's not a null, we're passing a value. Edinburgh, which satisfies a varchar, so we don't need a default. And 33, which satisfies the supplier score constraint of greater than 15. And if we execute, we get one row affected, select all from suppliers, we execute, and we now have computer repairs, Edinburgh, and supplier score 33. So all is right with the world again. Everything is moving as we want it to. And we've really observed the power of constraints and their core role in making our database sort of the single source of truth, which is really important to keep this clean. So play around with some of the other constraints, get used to them, and yeah, have fun doing it because it's one of those aha moments where you start to see the power of T-SQL.